This is the final sample problem for the work kinetic energy principle. A 40 kilogram object enters a 10-meter long strange tunnel with a speed of 7.0 meters per second and exits the opposite end of the tunnel with a speed of 11.0 meters per second. While inside the strange tunnel, three forces acted on the object. Force 1, a constant force of F in the opposite direction of the object's motion. Force 2 did 2,400 joules of work on the object. And force 3, described by the graph shown. Determine the value of F. Determine the value of F. So F was right there. That was an unknown amount of newtons that one of the forces was applying on the object. And it's in the opposite direction of the object's motion. That's very important. That means it does negative work on the object. Okay, so I'm going to just start listing stuff. So I know the mass. $40 kilograms. I know the starting speed and the ending speed, 7.0 meters per second and 11.0 meters per second. And then I have the three forces there. Okay, I won't list those out just yet. So the big picture is I have to determine the value of F, and this is going to apply to the work energy principle. Work net equals delta K, and as usual, I replace delta K with K2 minus K1. So when I look at this, I pause and I just ask myself, what part of this equation do I basically have all the numbers for, and what don't I have all the numbers for? So in terms of the K1 and the K2, these three things that I listed here are already enough to get the whole right side of this equation. Okay, K2, I can calculate that. K1, I can calculate that. Okay, so I don't even worry about that side of the equation at all. Now, in terms of net work, okay, well, the net work, there's three forces acting on this object, and they each do some work on the object. So my net work would be split up into work 1 plus work 2 plus work 3. So now I'm going to have to start looking at these three more closely. And the easiest one would actually be force 2, or work 2, because it says that it did, force 2 did 2,400 joules of work on the object. So that's the number exactly for work 2, 2,400 joules. So no worries there. And then I look at work 3, or force 3 is described by the graph shown. So I think back a couple of lessons ago, when I have a force versus displacement graph, I can calculate the work by getting the area. Okay, the area of this triangle is work 3. And I have the numbers for that. Okay, it says 10 meters there on the displacement axis. It says 120 newtons on the force axis. And I know how to calculate the area of a triangle. So I'm pretty solid for work 3 as well. Okay, I can calculate that. I'll just do that right now, actually. So this is the area. Work 3 is the area. So that's equal to base times height divided by 2, or half base times height. That's a half times 10 times 120. That'll be 600 joules. So work 3 is 600 joules. So I'm well on my way here. So then what I don't know is work 1. Okay, I can't calculate that because I don't know the force. Well, the force is what I want to calculate. And the force is what I'm trying to solve for in this whole thing. So what I'm going to do is I'm going to break W1 down into some kind of an expression that has force in it so that I can isolate for force. So W1 I'm going to replace with force times displacement times cosine theta, okay, plus W2 plus W3. All this other stuff is the same. So now when I look at what I just wrote, force, displacement, cos theta, what do I know out of those? Well, I know the displacement. The displacement is 10 meters. Okay, that's right at the beginning of the question. That's how long the tunnel is. Okay, so I know that. And I know the theta as well, because it says that it's in the opposite direction. Force 1 is in the opposite direction of the object's motion. So that means theta is 180 degrees. So I actually know my theta as well. So when I look at this equation and I see a check mark on every single thing, except for f, which is what I want to solve for, I'm pretty confident that I can solve that. It's just a matter of putting the numbers in and rearranging things. Okay, so I think I will, since I already know work 2 and work 3, what I think I'll do is I'll calculate K1 and K2 off to the side and then put those numbers in as well. Okay, so off to the side here, K1 half mv1 squared. So the mass is 40 and the v1 is 7. And that gives me 980, I believe. I'll just double check that. Yes, 980 joules. And then I'll do K2 as well. So the ending speed is 11, so 11 squared. So that's 2,420 joules. Okay, so all these values that I'm boxing in yellow, all right, they're going to go right into the equation, the 10 meters as well. Okay, so the equation is going to become force times 10 meters times cosine of 180, which is -1, plus 2,400 joules for work 2, plus 600 joules for work 3, equals 2,420 joules for K2, minus 980 joules for K1. So calculate out all those numbers. I'll do it in a few steps. So the first part, it's going to be -10F. And then 2,400 plus 600, that's 3,000. Then on the right side, 2,420 minus 980 is 1,440. Okay, so I will subtract 3,000 from both sides, giving me -1,560. Then I will divide both sides by a -10, giving me 156 newtons. And I'll do that to 2 sig figs. I haven't done scientific notation in a while, so I'll write that out now. It'll be 1.6 times 10 squared newtons. So that is how strong force 1 is. And note that that acts in the opposite direction of the motion. All right, so that's how you solve this one. There's a whole ton of other variations I can do for these strange tunnels. I can add friction to the situation. Could add gravity to the situation. Actually, sample problem 2 had gravity in it. So, I mean, I could do sample problems on and on and on and on, and I still would not be able to show you every single one of them. Okay, so it's important that you don't try to memorize all these techniques. You don't try to memorize the setup of every question and the solution to all of that. You just have to be flexible. Okay, you just have to start with the work energy principle and just use flexible problem solving skills to solve for whatever unknown it is that they ask you for. Okay, so I'll give you some practice problems for that. I also posted a challenge problem for this week. There's no problem set this week. There will be. Oh, sorry, no, there is a problem set this week. So I'll post a challenge problem, and it can be like an optional problem. So you can do one less problem on your problem set if you can do the challenge problem. All right, good luck with everything.